Okay, for this review problem, we're going to prove that if n squared is even and n is an integer, then n is also even. The proof of this one will be done by contrapositive. Before I start the proof, I wanted to mention that this theorem is actually used in the proof that the square root of 2 is irrational. When we proved the square root of 2 is irrational, we had m squared was even, which would imply that m was even. We needed that a couple of times. So we kind of stated that in class but didn't prove it. It made sense. Here we're actually going to prove it formally. So we're going to prove this, and the proof will be by contrapositive. Okay, so by contrapositive, so we're going to assume the negation of the conclusion. Suppose that n is odd. Then by definition, there is an integer k so that n is equal to 2k plus 1. That's what it means to be an odd number. So let's take a look at what n squared is. Therefore, n squared will be equal to 2k plus 1 squared, and the goal is to show that this is an odd number, thus proving the negation of hypothesis. To show that this is an odd number, we'll multiply it out, 4k squared plus 4k plus 1, and that's equal to 2 times 2k squared plus 2k plus 1. Now that's an unusual way to simplify things. First we left out the plus 1 because we want to show that it's odd. And on these two terms I factored a 2 out. Now I could have hypothetically factored out 4k. After all, there's a 4k here and there's a 4k in this first term. But all I need is to factor the 2 out to show that this is an odd number, 2 times something plus 1. Now the something here is an odd number, or some reason an integer, I apologize. By the axioms of arithmetic, 2k squared plus 2k is an integer. 2 is an integer, k is assumed to be an integer, and if I multiply integers and add integers, the result must be an integer. Therefore, n squared is odd by definition. So, in conclusion, we have thus proven that if n is odd, then n squared is odd, which is the contrapositive of what was to be proven. And so that's the end of the proof, and then we use some kind of end of proof symbol to denote that that's the end of the proof.